Hey, everyone. Oh, hey, Sarah.
Hey, Francesco.
All good. Did you have the chance to see my latest camera app?
No, I haven't seen it yet, but I hope you tested on a tablet.
Of course, it's the form factor day. Look how gorgeous it looks on a tablet.
Oh, wow, it looks great. Wait, but what if I want to rotate the tablet?
She wants to rotate the tablet. Why?
Well, for many reasons. Maybe for a different angle, for better ergonomics, things like that.
I mean, I guess we can give it a try. Yeah, that was kind of unexpected, I would say. I locked the orientation for the activity in the manifest, so I was expecting the preview will look like okay-ish.
Yeah, well, that might be okay for still on Android 11, but don't you know now that the OEM can override the chance to lock the orientation?
Yeah, I kind of heard about it, but yeah, I thought it would look okay in any case.
Yeah, let me quickly explain what's happening here. You might think it's as simple as just rotating the image, but there's actually 3 types of orientation you have to think about now.
3 types of orientation. Okay, go ahead, I'm listening.
Let's start with the basics. Do you know what natural orientation is?
Yeah, I heard. Please go on.
Yep. So natural orientation is the orientation that a user will naturally use a device in. So you can imagine it's something like landscape for a laptop or portrait for a phone. For a tablet, it could be either of these 2. So starting from this, we can then define 2 other major concepts. So next, camera orientation is the angle between the camera sensor and the natural orientation of the device. This is likely dependent on how the camera is physically mounted on the device, and it is always supposed to be aligned with the long side of the screen.
Okay, it is always supposed to be aligned with the longest side of the screen. I have a question. What's the longest side of the screen for a foldable device, as it can physically transform its geometry?
That is a great question. Let's check out the next example. So as you noted, a foldable can have a portrait-shaped window if it's folded and a landscape-shaped window if it's unfolded. For this very reason, starting in API 32 and beyond, this field is no longer static, and instead you should retrieve it dynamically through the camera characteristics object.
Okay, if it's not static, but that means that the same physical camera can have 2 different orientation depending on the screen you're using it?
Yes, exactly. So if you look at the picture here, you can see what can happen if you assume that the camera orientation always stays the same. It can cause mismatch between the camera orientation and the device's natural orientation, which can lead to distortion.
Okay, I guess that means I should never cache this value.
Yep, and not just for new form factors. In general, you should not store it and instead retrieve it dynamically anytime you need it by calling this code.
Okay, noted. Now what?
So next, we need to take into account the device rotation. This measures how much the device is physically rotated from its natural orientation.
How much the device is physically rotated from its natural orientation? Is it like degrees or what?
So basically, you'll get an integer between 0 and 4 by calling display.getRotation, and then you can convert it to degrees by multiplying the result by 90. And then the result will be consistent with the sensor orientation that we just discussed.
Okay, well, I guess I can deal with that, but just for the preview, we have been looking at the device geometry, the camera characteristics, and data from the display stack. Is anything else I need to know?
Nope, this is pretty much everything. The actual math is pretty simple. Let's take a look at the code. So here we can see a code snippet that computes the rotation required in degrees to transform the sensor output orientation to the device's current orientation. The rotation needs to be either clockwise or counterclockwise, depending on if the camera is facing the front or back of the screen. And then we basically just calculate the difference between the 2 concepts we just discussed with a little bit of math to make sure that the value is always between 0 and 360 degrees.
Okay, now I see why my app was sideways. Having locked the orientation in the portrait, I thought I was assuming I could avoid dealing with all of that. But, let's get back to my app and try to apply this algorithm. So this tablet has a natural orientation portrait. That means the sensor orientation is 90 degrees. But I just rotated it, and now the display rotation is 90 degrees too. If I'm still good at math, it's just 90 minus 19. So the right rotation to be applied is 0.
Yep, that's correct. But then why are you applying 90?
Well, I haven't applied any rotation. I just used the default values.
That explains the issue. By default, texture view will take into account the sensor orientation, but not the display rotation.
Okay, now I see why for the portrait mode I didn't need to do that much. Okay, let me fix it, run it again, pretending it's compiling. Go ahead. There we go. Thank you.
Yay. Great job. Wow. Can I ask you another favor, though?
Another favor she wants to ask. Okay, go on.
So the tablet has a lot of screen space.
Mhm.
Can you quickly throw up maps and split screen? It shouldn't be an issue, right?
It shouldn't. Okay, let's try. So we have the taskbar, we grab maps, and what happened? Okay, I see why you asked this favor. So I guess there's a lesson to learn, so please go on.
Yep. So handling the orientation alone does not guarantee a correct camera preview. For example, in multi-window mode here, you might need to display a landscape-shaped camera output into a portrait-shaped window. And as we see here, without the right transformation, you might end up with a display that's distorted or shrunken. So you'll either need to crop the image like this, or scale it to match the aspect ratio, depending on your use case, like this.
Okay, that totally makes sense, but how do I do that?
So we have a manual solution for Camera 2. It might take a little bit too long to explain here, but I will leave the link here for your reference. I really suggest, though, that unless you need to use the surface directly, you take advantage of the libraries that we've built for you to help in this task.
Sure, libraries like CameraX.
Exactly. Jetpack CameraX can be the right solution because it automatically transforms the preview for every screen size and handles the camera lifecycle through different configuration changes or through multi-resource access. So CameraX also releases are continuous and is continuously updated and tested on different devices, so you'll ensure the best compatibility.
Okay, that sounds amazing. The only thing is, I'm already using all those Camera 2 APIs, and I haven't migrated yet to CameraX. Is there a solution for me?
Yep, no worries. We do have something for Camera 2. So we just released a new artifact that does not depend on CameraX core. It's called Camera Viewfinder, and you can basically substitute your raw surface directly with it and let the library handle all of the nuances for you.
That sounds perfect, but how come I didn't know about it?
Because we just released it today.
Woo!
Yay! You can check out how to use it at the link here.
Okay, wonderful. Okay, let me just look at the code right now. Okay, so I see at the beginning, we choose the resolution we want for the preview as usual. And then we build this request. And then we get this callback. And when the surface is available, if everything went well, we can just use that surface with the standard Camera 2 APIs as always, instead of, getting the surface from the texture view, the surface view, applying the rotation. And that's it.
Yep, that's it. Camera Viewfinder will take care of all the orientation and aspect ratio considerations for you.
Amazing. Well, I guess I don't have excuses anymore. I need to go update my app.
Good luck. Hopefully the resources we talked about today will be helpful for you, and I hope all of you are also encouraged to test your camera apps on different devices and form factors.
Thanks for your time today, and have fun with your camera app.